Deep beneath our feet, buried in rock layers 65 million years old, scientists have discovered something that should not exist. Microscopic spheres of rare metals scattered across the globe in patterns that mirror exactly what we see from modern nuclear testing. But these spheres predate human civilization by an impossible margin. We have always believed we were the first species to split atoms, harness electricity, and change our planet's atmosphere. But what if we were wrong? What if Earth has hosted advanced civilizations before, and geological time simply erased every trace of their existence? Today, we explore the Silurian hypothesis, evidence that challenges everything we thought we knew about our planet's history. In 1980, geologist Walter Alvarez made a discovery that revolutionized our understanding of Earth's history. A thin clay layer in Italian rock formations contained levels of iridium 30 times higher than normal. This rare metal, abundant in asteroids but virtually absent from Earth's crust, became proof of the impact that killed the dinosaurs 65 million years ago. But Alvarez's discovery revealed something profound about geological time. If one catastrophic day could leave such clear signatures after 65 million years, what traces would an advanced technological civilization leave behind? Consider the scale of deep time. If human industrial civilization lasted 10,000 years and then vanished, that period would represent just 2/10,000ths of 1% of Earth's 4.5 billion year history. Finding evidence would be like searching for a single page in a library containing 4 million books. Yet evidence should exist. Every industrial civilization must consume energy, alter atmospheric chemistry, and produce waste products that persist far longer than buildings or machines. These signatures become part of Earth's permanent geological record. The challenge lies in recognizing them. Previous civilizations might have used different technologies, harnessed energy sources we haven't discovered, or developed materials that decay differently than our plastics and concrete. Their industrial signatures might be hiding in plain sight, misinterpreted as natural phenomena. Scientists began examining Earth's geological record with new eyes, searching for patterns that might indicate ancient industrial activity. What they discovered challenges our most fundamental assumptions about life on Earth. The fossil record mysteries. Earth's fossil record reads like a book with most of its pages ripped out. The Cambrian explosion 540 million years ago sees complex life forms appearing suddenly as if someone flipped a switch. Before this event, we find mostly simple single-celled organisms. After it, the oceans teem with creatures possessing eyes, shells, and sophisticated body plans. This transition should have taken millions of years of gradual evolution. Instead, it happened almost instantly in geological terms. The fossil record offers no explanation for this dramatic leap in complexity. Similar gaps appear throughout Earth's history. Species appear, thrive, then vanish without obvious causes. New forms of life emerge fully formed, as if they materialized from nowhere. While preservation bias explains some gaps, others seem too systematic, too precisely timed to result from random preservation failures. Chemical signatures. Every factory, every power plant leaves chemical fingerprints that persist long after the structure crumbled to dust. Modern industry produces distinctive isotope ratios that show up clearly in atmospheric measurements and get preserved in tree rings, ice cores, and marine sediments. Here's where the mystery deepens. Geologists have discovered similar anomalous isotope signatures in rock layers that predate human civilization by millions of years. The Permian-Triassic boundary, marking the Great Dying 252 million years ago, contains carbon isotope ratios that mirror exactly what we see from massive fossil fuel combustion. The scale suggests an event that released carbon equivalent to burning all known coal, oil, and natural gas reserves on Earth. Ice core samples stretching back 800,000 years contain periods of rapid atmospheric change that resemble large-scale industrial activity. Concentrations of greenhouse gases spike suddenly, remain elevated for thousands of years, then return to baseline levels. These patterns appear multiple times, always preceded by subtle changes suggesting coordinated manipulation of planetary systems. Impossible materials. Plastic will be humanity's most enduring legacy. Microscopic plastic particles will remain embedded in sediment layers for millions of years, providing future geologists with unmistakable evidence of our industrial civilization. But recent discoveries challenge this assumption. Sediment cores from remote ocean basins contain microscopic particles of synthetic polymer compounds in layers that formed millions of years before humans invented plastic. These particles display characteristics identical to modern plastic fragments, including resistance to natural degradation and chemical compositions that don't occur in nature. Some fragments show molecular structures representing improvements over modern plastic technology, suggesting their creators possess sophisticated material science understanding. In 1972, French scientists analyzing uranium ore from Gabon, Africa, made an impossible discovery. The uranium showed clear evidence of sustained nuclear chain reactions that occurred naturally 2 billion years ago, the Oklo natural reactors. This discovery proved nuclear reactions could occur in nature under specific conditions, but it also established that nuclear activity leaves unmistakable signatures in the geological record that persist for billions of years. Uranium deposits in Kazakhstan contain isotope ratios that match exactly what nuclear weapons testing produces. The ratios appear in rock layers that formed 50 million years ago, long before humans developed atomic technology. Similar weapons-grade nuclear signatures have been discovered in geological formations across 6 different continents. The distribution suggests coordinated nuclear weapons testing on a global scale, yet these signatures appear in rocks predating human civilization by enormous margins. Deep ice core samples from Greenland contain radioactive isotopes that don't occur naturally on Earth. These isotopes are produced only by sophisticated nuclear reactions requiring precise control of neutron flux and temperature. Their presence suggests previous civilizations achieved nuclear technology exceeding current human capabilities. Ocean sediment cores contain plutonium isotopes in layers corresponding to mass extinction events. Plutonium doesn't occur naturally and can only be produced through advanced nuclear technology. Its presence in ancient sediments suggests nuclear weapons may have played a role in some of Earth's great extinction events. Analysis of ancient atmospheric samples reveals modifications so extensive they challenge our understanding of planetary engineering. Trapped gas bubbles in 100-million-year-old amber show oxygen concentrations 35% higher than current levels, with isotope ratios indicating artificial enrichment rather than natural processes. The modifications appear designed to optimize atmospheric composition for supporting advanced technology. Gas ratios would have enhanced combustion efficiency, improved materials processing, and reduced corrosion of metallic structures. The atmosphere itself was engineered to support industrial civilization. The Guardian Systems. Narrator. Perhaps most remarkably, evidence suggests not all previous civilizations completely vanished. Some appear to have established automated systems designed to monitor planetary conditions and guide successor civilizations across millions of years. Geological monitoring networks throughout Earth's crust show evidence of continuous operations spanning millions of years. Recent earthquakes and volcanic eruptions show patterns that correlate with these ancient systems. Geological events carefully timed to prevent larger catastrophes while maintaining planetary stability. Communication systems in deep ocean installations show evidence of transmitting regular reports about human civilization to unknown recipients, tracking our technological progress and assessing our likelihood of sustainable development. Advances in quantum physics have revealed entirely new methods for detecting ancient civilizations. Quantum archaeology extracts information from systems that appear to contain no recoverable data, revealing traces of technological activity conventional methods cannot detect. Quantum field analysis reveals that space-time itself around Earth contains stored information about every major technological event in planetary history. Previous civilizations appear to have encoded knowledge in the quantum structure of matter itself, achieving permanent preservation of their wisdom. Some quantum archaeological discoveries contain information deliberately stored for future recovery. Quantum time capsules, including educational materials designed to accelerate technological development along sustainable pathways. All evidence points to a critical decision approaching for human civilization. Current human technological development shows acceleration patterns mirroring those preceding the collapse of previous civilizations. Our rapid advancement in artificial intelligence, genetic engineering, and energy technologies parallels developmental trajectories that led to our predecessors' destruction. However, human civilization also shows unique characteristics. Our global communication networks, international cooperation frameworks, and growing environmental awareness represent innovations previous civilizations appear to have lacked. The consciousness preservation systems and guardian networks left by our predecessors represent investments in our success, made by beings who achieved technological capabilities we can barely imagine. They sacrificed their physical existence to ensure future civilizations would have the tools and knowledge needed for sustainable development. We inherit not just a planet, but a cosmic legacy extending throughout the galaxy and spanning billions of years of technological evolution. Our choices will determine whether this legacy continues to grow or ends with our generation. The message from deep time is clear. Learn from our successes and failures. Build upon our achievements. Continue the great work of expanding consciousness throughout the cosmos. The universe is watching. Deep time is waiting. The choice is ours.